Okay, so welcome to section 8.3, which is voting theory. Okay, so the first thing we're going to deal with is preference schedules. Okay, so definition. Okay, so a preference ballot, that's what we're defining. A preference ballot. Preference ballot. Pardon me, ballot. So a preference ballot has the voter rate their choices from first to last. So has the voter rate their choices. Rate their choices from first to last. From first to last. Okay, so for example, so suppose 13 people vote on their preferences. So suppose 13 people vote on their preferences. Their preferences between let's do dogs, which we'll call capital D, cats, which we'll call capital C, and rabbits, which we'll call capital R. Okay, so let's recall that how many ways can I arrange 3 items? So let's recall. So there are 3 factorial equal to 6 ways to arrange or permute 3 choices. So ways to arrange or permute 3 choices. And that's what we have here. We have 3 choices. So let's see if we have 6 overall. So what I'm going to do, I'm going to set up a table with the voters and each of their choices. So we'll call voters will be on the horizontal. So we'll have voter 1, voter 2. There's 13 of these guys. Voter 3, voter 4, voter 5, voter 6, voter 7, voter 8, voter 9, voter 10, voter 11, voter 12, and last but not least, voter 13. Oops. Let me draw that a bit closer. So voter 13, and I'll draw the last bar here. Okay, so now I want to say what is their first, second, and third choice. So let's do first choice here. Second choice here. And then third choice here. So I guess I should have made those a bit longer. Okay, so each voter has one column and three choices: dogs, cats, or rabbits. So how does each voter choose? So first, I'm going to deal with dogs. So we'll do dogs in purple, shall we? So let's choose purple for dogs. So for voter 1, dogs is last. For voter 2, dogs is first. For voter 3, dogs is first. For voter 4, dogs is second. For voter 5, dogs is last. For voter 6, dogs is last. For voter 7, dogs is last. For voter 8, dogs is second. For voter 9, dogs is first. For voter 10, dogs is first. For voter 11, dogs is second. For voter 12, dogs is last. And then for voter 13, dogs is first. So this is how people chose dogs. Now let's choose cats in blue. So for voter 1, cats was first. For voter 2, cats was second. For voter 3, cats was third. For voter 4, cats was first. For voter 5, cats was first. For voter 6, cats was second. For voter 7, cats was first. For voter 8, cats was last. For voter 9, cats was second. For voter 10, let's see, where cats was last. Let's make cats last. For voter 11, cats is first. For voter 12, cats is first. And then for voter 13, cats will be second. Okay, so now let's do rabbits. And let's use, I guess, orange. So rabbits will be in orange. So it's clear that rabbits fill in the remainder. So for voter 1, it's second. For voter 2, it's third. For voter 3, it's second. For voter 4, it's third. For voter 5, it's second. For voter 6, it's first. For voter 7, it's second. For voter 8, it's first. For voter 9, it's third. For voter 10, it's second. For voter 11, it's third. For voter 12, it is second. And for voter 13, it is last. Okay, so even though there's 13 voters, I claim that there's only really 3 factorial or 6 ways to arrange these. So now I'm going to consider a vote versus frequency chart. So vote versus frequency. So frequency. Frequency. Let's call this little f. Okay, so let's first look at this. Let's do pink. So how many times do I have the vote C, R, cats, rabbits, dogs? So that's what's in the first place, right? Actually, let me see. I can move this up a bit. Okay, so how many times do I have cats, rabbits, dogs? So voter 1 looks like voter 5, cats, rabbits, dogs. Voter 7, cats, rabbits, dogs. Voter 12. So it appears as though I have 4 of those guys. Okay, now the next one will be dogs, cats, rabbits. So dogs, cats, rabbits. And let's do that in green. So that's the second voter. So dogs, cats, rabbits. So it looks like voter 2 and voter 9 and voter 13. So it looks like there's 3 of those guys. Now let's do dogs, rabbits, cats. Which let's do that in, what color should we use? I guess we'll use yellow. So that's voter 3. So dogs, rabbits, cats also is voter 10. So it looks like there's only 2 of those. So 2 of those, okay. The next one will be cats, dogs, rabbits. So cats dogs, rabbits. Let's do that in hot pink. So cats, dogs, rabbits. Voter 4 and looks like voter 11, and that's about it. So there's only 2 of those votes. So the next one is rabbits, cats, dogs. So rabbits, cats, dogs. How many of those votes did we get? Let's do that in dark purple. So pardon me, rabbits, cats, dogs. Oh, well, that's it, just once. Okay, just one of those. So 1, 2, 3, 4, 5. We should only have one more permutation on these, and let's call it rabbits, dogs, cats, right? So rabbits, dogs, and cats. And if we've done everything right, there should only be one more unchecked guy, and that's voter 8. So there's 1. Okay, and let's make sure that the frequencies add to 13. So if I add these all together, 1 plus 1 is 2, plus 2 is 4, plus 2 is 6, plus 3 is 9, plus 4 is 13. So check mark. So we get all of our voters. But notice there's only 6 different permutations of this. So what I'm going to do, let me use, what color should I use? Teal. I'm going to translate these into a frequency table. So what I'm going to do is I'm going to put the frequency of the first, second, and third guys. Two, 3, 4, 5. We only have 6 permutations, so I need 6 rows. And then we have first place, oh, 1, 2, 3, 4, 5, 6. Oops, I'm missing 1. So first place, second place, and then third place. So we can basically, all we need to do is have 6 factorial boxes, like so, or, sorry, 3 factorial boxes, 6 boxes. So, do you agree that the frequency of 4 was the order cats, rabbits, dogs going down? So that had a frequency of 4, the first guy I listed. The next frequency was 3, and that guy was listed as dogs, cats, and rabbits. The next most frequent guy was 2, and that guy was dogs, rabbits, cats. So dogs, rabbits, cats. The next most frequent permutation was cats, dogs, rabbits. So cats, dogs, rabbits. The next was, I think I used this dark purple, a frequency of 1. That was rabbits, cats, dogs. So rabbits, cats, and dogs. And then finally, the last frequency of 1 was rabbits, dogs, cats. So rabbits, dogs. So these represent cats. These represent the 6 permutations of the 3 possible choices. So this is what's known as a frequency table. Let me actually move this a bit. Up here, maybe. Yeah. Is that too close? Maybe I'll move it out there. Okay. Yeah. Maybe I'll move it down one. It seems too close to what's on top there. Okay. And what I'll do is I will make this a bit longer. So all of this gets translated into this frequency table. Okay, so definition. That's a lot of work, isn't it? So definition. So the plurality method of voting. So the plurality method of voting. That's what we're defining. The plurality method of voting. It chooses the first choice with the most values. So it chooses the first choice. And let me. So above the first choice would be these guys. So the first choice with the most votes. So with the most votes. I.e. highest frequency. I.e. highest frequency. Okay, so note. Let's note something about pluralities. So note, a plurality is not necessarily a majority. So a plurality is not necessarily a majority. Really a majority. And I'll show this in a moment. Remember, a majority is more than 50%. Okay, so for example, so consider the following preference ballot. So consider the following preference ballot. Preference ballot. So what I'm going to do is I'm going to just have a frequency chart because that's easier. Frequency, let's see. So I'm going to have first, let's see, 1, 2, 3, 4, 5. I'll just do five different frequencies here. 2, 3, 4, 5. So let's say one of the permutations didn't show up in this voting. So second. And third. Okay, so I'll say, let's have a frequency of 4 for the order. Let's do cats, dogs, rabbits. That's why I should not have used orange. Let's use hot pink for that instead. Now let's do a frequency of 3 for the order dogs, cats, rabbits. So dogs, cats, rabbits. Okay, the electricity is going crazy here. Hopefully it'll hold out while I'm doing this. Okay, now let's do a frequency of 2 for the order of dogs, rabbits, cats. Dogs, rabbits, and cats. And let's do a frequency of 2 for the order cats, dogs, rabbits. Cats, dogs, rabbits. And let's also do another frequency of 2. Oh boy, what color should I use? I've already used dark purple. What should I use? Maybe darker blue. Let's use red. How about red? So another frequency of 2 for the order rabbits, cats, and dogs. Okay. So who has a plurality? Well, it looks like cats have a plurality. Because if I look at the number one vote with, looks like there's 4 plus 2 equals to 6 votes, or actually number one votes. And then who's next? Dogs have 3 plus 2. 3 plus 2 equals to 5 votes. Number one votes, that is. And then rabbits have 2 votes, right? So note about this. Let me actually move this up. And I'll put an asterisk. So let's note total votes is equals to 6 plus 5 is 11 plus 2 is 13. So what's interesting is 6 out of 13 is less than 6 out of 13 is less than 50%. It's less than 50%. So it's not a plurality. Even though cats have the most votes, it's not a majority. I'm sorry, I spoke incorrectly. It is a plurality. It's not a majority. Okay, so hopefully that makes sense. Okay, so now definition, the Condorcet criterion. So definition. So the Condorcet criterion. Condorcet criterion. That's what we're defining. Okay, so states that the person who wins in a 2-candidate election, so the person who wins, person or cat, so the person who wins in a 2-candidate election, a 2-candidate election with each distinct other candidate wins overall. Okay, so what does this mean? So, for example, so let's use the Condorcet criterion. So use the following. How do I want to say this? The Condorcet criterion with the following preference ballot. Preference ballot. Okay, so do you know what I'm going to do? I'm just going to go ahead and use this preference ballot that we've already have, so you can just copy and paste it. Copy and paste, so we're not having to make a new one up each time. Okay, so this is the results. So the Condorcet criterion says that in a 2-candidate, election. So what I want to do is, let's do first cats versus dogs. So cats versus dogs. So I'm just going to go ahead and erase the rabbits from here. So paste. So cats versus dogs. I would no longer have rabbits, right? So let's get rid of the rabbits here. And now we're going to look at what are the numbers? So what do cats have? Cats have, let's see. Well, now cats have 4, 2, and 2, right? Because rabbits don't exist. So cats will be equal to 2, 4, 2, 4, 4, 2, and 2 is 8. So that's 8 out of a total of 13. We know that is 13 votes. And dogs have 3 and 2, so they have 5 out of 13. Okay, so cats win. Cats win in this one. So now let's see if cats win when we compare cats to rabbits. Because we need to compare cats to each other guy in the election. So there's only 2 guys with cats. There's cats with dogs and cats with rabbits. So now let's see if cats win when we versus them with the rabbits. So cats versus rabbits. So now we'll just erase dogs. Okay, so we have our frequency table. Let's erase dogs from this table. Okay, so now let's see, what do cats have in this one? They have 4, plus 3 is 7, plus 2 is 9. So in this case, cats will be 9 out of 13. 9 out of 13. And rabbits will be 2, 4. So rabbits are 2 out of 13. Sorry, 4 out of 13. Addition, not my strong suit. 4 out of 13. Okay, so do you agree that in this case, why did that just make a circle? That's weird. I want the number 4. So 4 out of 13. So in this case, cats win once again. So because cats won in a 2 off with every other candidate, cats win. Okay, so cats win overall. Cats win with the Condorcet criterion by the Condorcet criterion. Condorcet criterion. Okay. So now let's do the instant runoff voting. So definition. So instant runoff voting. Instant runoff voting, that's what we're defining. And it's annotated IRV. Continually eliminates the least popular first place vote. So continually eliminates the least popular first place. So popular first place vote. First place vote in a preference ballot. In a preference ballot. So like we've been dealing with before. So until such time. So until such time as any of the remaining votes, the remaining, I should say, first place votes, the remaining first place votes has a majority, not a plurality, a majority, has a majority. And a majority that is over 50%, or 50% of the votes. Okay. So let's see. Do you know what? I think I'm going to give myself a bit more room here. I'm going to move this down a bit. Couple lines. Maybe give myself some space with these guys here. Move them down at least one line. Okay, hopefully that's a bit more spacious. Okay, so for example, so consider an animal preference chart. So consider an animal preference chart. Animal preference chart. Preference chart. Listing cats, C. Dogs, D. Dogs, capital D. Rabbits, capital R. Horses, capital H. And fish, capital F. So hopefully those are all different letters. So find the most preferred animal using IRV. So find the most preferred animal. Preferred animal using instant runoff voting. IRV, instant runoff voting. Okay, so let's say we have a frequency chart here. And let's do 1, 2, 3, 4, 5, 6, 7, 8. Let's do 8. And 5 we have, let's do 5 guys. So 1, 2, 2, 3, 4, 5, 6, 7, and 8. So we'll have 8 different frequencies. And there's 5 animals, so I need 5 choices. So first, second, third, fourth, and fifth. So first, second, third, fourth, and fifth. So I need to go down a little bit more. Okay, so first choice, second, third, fourth, fifth. Okay, so let's say a frequency, I'll just do 5, 3, 4, 7, 6, 4, 2, 2. Make you up frequencies. Okay, let's say that the first chart looks like, well, the first chart has cats first. The second column has cats second. The third column has cats second. The fourth column has cats first. The fifth column has cats third. The 6th column has cats 4th. The 7th column has cats 3rd. And the final column has cats last. So we'll do that for cats. Now let's do dogs in purple. Okay, so the first column has dogs 3rd, then dogs 1st, then dogs last, then dogs 2nd, then dogs 1st, then dogs 2nd, then 2nd to last, and 2nd to last. Okay, we'll do rabbits in orange because that's what we are used to. So the first column has rabbits 2nd, then rabbits 4th, then rabbits 1st. Oh, what just happened? I hope nothing bad just happened. Okay, then rabbits, let's see, 3rd, then rabbits 4th, then rabbits 3rd, then rabbits 1st, then rabbits 2nd. Okay, so now I need new numbers. So let's do, I think I'll do pink for horses. So horses, let's do pink for horses. So the first column has horses last, then horses last, then horses 3rd, then horses 4th, then horses 5th, then horses 1st, then horses 5th, and horses 3rd. And finally, let's do fish in gold. So fish just fills in the rest. So 4th, 3rd, 4th, 5th, 2nd, 5th, 2nd, and 1st. Poor fish. Okay. So let's look at our first place votes. So first place votes. First place. We only really care about who's in first place because we're going to eliminate the least popular first place vote. So we have cats, and that is going to be 5 plus 7. 5 plus 7 is what? 12? So 12 out of, and how many do I have here? 5 plus 3 is 8. 8 plus 4 is 12. 12 plus 7 is 19. 19 plus 6 is 25. Did I do this right? 8, 12, 19, 25, 29. Okay, so I'm up to 29. Plus 4 is 33. Okay, just making sure I can count. So 12 out of 33. The next one is dogs. And that's a frequency of 3 plus 6 is 9. So that's 9 out of 33. Then let's do rabbits. So the frequency of rabbits is 4 plus 2 is 6 out of 33. And then horses was pink. So horses, that's going to be 4 out of 33. And last but not least, we had fish. And that was simply 2 out of 33. So the least popular first place vote is fish. So what we're going to do is eliminate. So let's go ahead. And what we're going to do is get rid of fish. Okay, so now I'm going to copy and paste this. But what I'm going to do is I'm going to shift everything up. I don't know if I have to, but let's copy and paste. Okay, the electricity was off for hours last night. I hope it doesn't go off while I'm doing this. Okay, so now I'm getting rid of fish, so let me go ahead and eliminate fish. So that's really only going to affect the last column, right? So now the first place here is going to be a rabbit, right? Okay, so let's look at the first places again. So first place. First place. Do you know what? I might want to move this down just a bit. Depends on how much space I'll have, but let's move this down just one. Okay, so once again, let's look at cats. Cats is now 5 plus 7 is 12. So that's 12 out of 33. Then let's look at dogs. Dogs is 3 plus 6, that's 9. So dogs is equal to 9 out of 33. Oh, then what did I do next? Rabbits. Okay, let's do rabbits next. That's 4 plus 2 is 6 plus 2 is 8 now. Notice rabbits increased because we got rid of fish. So rabbits is now 8 out of 33. And then last but not least, horses. Horses are 4 out of 33. So horses are 4 out of 33. Okay, so the least first place vote in this case has become horses, so I need to eliminate horses. Nope, okay, it's not letting me put a square around this. Don't know why. Oh, there we go. Okay, so we're eliminating horses. Okay, so I'm going to just copy and paste this again. Actually, let me copy this guy because he's already eliminated rabbits. So copy and paste. Okay, I've eliminated rabbits. Now let's eliminate horses. So we'll take the horses away. So that's only going to open up one first place position. And that first place position is now taken up by dogs because this dogs moves up. Okay, so let's look at the first place. First place again. Okay, so starting with cats. So cats is still 5 plus 7 is 12 out of 33. Then moving on to dogs is 3 plus 6 is 9 plus 4 is now 13. So dogs have increased. So dogs is now 13 out of 33. Rabbits are now, we have 4 plus 2 is 8 out of 33. Okay, so the least popular animal at this point is now rabbits. So I can get rid of rabbits. Nope, okay, why? There we go, okay. So let's get rid of rabbits. And let's do this again. We've only got one more to do, right? Because, oh, oops, I forgot to erase that horse. Because it's only between cats and dogs at this point. So let me copy. And we'll move down to the next page and paste. Would I have enough room if I didn't? No, that's okay. Okay, so now I'm getting rid of rabbits. So I have to erase all the rabbits here. So erasing rabbits. Okay, so what that does is it moves cats up here and up here and another dog up here. Okay, so now let's look at the first place guys here. So first place. We're only dealing with 2 guys now. So cats is going to be 5 plus 7. Oh no, 5 plus 12. 5 plus 7 is 12, plus 4 is 16, plus 2 is 18. So that's 18 out of 33. And dogs is going to be 3, plus 6 is 9, plus 4 is 13, plus 2 is 15 out of 33. Okay, so what happens in this final round, instant runoff voting? Dogs are eliminated, so cats win by instant runoff voting. So cats win by instant runoff voting IRV. Okay, so I think that is it for this section. I will see you in the final section of the course.